All right, let's dive into one of the most clever and honestly one of the coolest shortcuts in artificial intelligence right now, reservoir computing. It's this amazing framework that is totally flipping the script on how we think about training really complex AI models.
So let me just start by asking you this. We all know the hardest, most time-consuming, and frankly, the most expensive part of building a lot of AI is the training. But what if we could just skip a huge chunk of that? What if we could sidestep the hardest part entirely?
Well, the whole idea here is to use a system that's already complex, a reservoir, and treat it like a computational black box. We don't have to build it, we don't have to train it, we just use it. It's like we're outsourcing all the really heavy lifting to something that does it naturally.
Now, to really appreciate just how big of a deal this shortcut is, we first need to get a handle on the problem it's solving. So why is training certain types of AI so incredibly difficult to begin with?
The real challenge comes down to a special kind of AI called a recurrent neural network, or an RNN. Now, these things are super powerful for dealing with data that comes in a sequence, like language or predicting things over time. But getting them to actually learn involves training millions of connections, and that is just a massive computational headache.
And this right here, this lays out the difference perfectly. With the old school networks, you have to train everything. It's super expensive and just incredibly complex. But with reservoir computing, you leave the complicated part, the reservoir, completely alone and only train the very simple output layer. The savings in money, time, and complexity are just staggering.
And check out this quote from the research. It just nails the key point. The complex behavior of the reservoir, it's fixed. It is what it is. All the learning, every single bit of training happens in one super simple place. The readout stage. That's the magic trick that makes this whole thing work.
Okay, I know this whole reservoir idea might still feel a little out there. So let's make it super concrete with a fantastic analogy that researchers actually use, a simple bucket of water. But before the fun analogy, here's the quick technical definition. The reservoir is basically any system that has fixed, complex, and non-linear behavior. Its whole job is to take a simple input and just blow it up into a much richer, more detailed pattern. Think of it as an amplifier for complexity.
Okay, let's see how this plays out. First, your input signal. Imagine dropping a single pebble into a bucket of water. Simple, right? Second, the reservoir dynamics. The water, our reservoir, instantly reacts, creating this beautiful, intricate pattern of ripples. That pattern is way more complex than the initial pebble drop. And finally, the readout. We have a camera pointed at the water, and we only train the camera to connect certain ripple patterns with certain answers.
And this is the punchline. This is the whole thing. We never ever try to teach the water how to make better ripples. That would be insane. We just accept its natural, complex physics for what it is. The only part that learns anything is the super simple camera that just interprets the results. We're basically getting all that complex computation from the water for free.
And what's amazing is that a reservoir can be almost anything that has these properties. It can be virtual, like a computer simulation of neurons with random fixed connections, or, and this is where it gets really mind-bending, it can be a physical system, a literal bucket of water, the way light behaves in a laser, or as we're about to see, even quantum systems.
So, this is a pretty fascinating idea, right? But what is it actually good for? Let's take a look at the real-world applications and see how this clever idea turns into a seriously powerful tool. It turns out reservoir computing is a total rock star at anything that involves time and sequences. And that matters because it means we can efficiently tackle incredibly hard problems, like predicting chaotic systems, think weather patterns, or unscrambling mixed-up signals. But people are also using it for things like language processing and even for learning motor control, kind of like how our own brains work.
Now, if using a bucket of water as a computer wasn't wild enough for you, let's look at where this is all going next. And trust me, you're going to want to buckle up because we're heading to the quantum frontier.
This is the next giant leap, right? The quantum world is, by its very nature, one of the most complex, high-dimensional, and frankly, weirdest systems we know of. So, what happens when we try to use that natural, mind-boggling complexity as our reservoir?
Well, researchers are already doing it, and the things they're using for quantum reservoirs sound like science fiction. They're looking at the quantum spins of atoms, lattices of tiny quantum dots, networks of interacting quantum oscillators. They've even got this principle working on IBM's own quantum computers.
And this quote just captures the excitement perfectly. This isn't just a small step forward, it's the birth of a whole new field called quantum neuromorphic computing, which is a fancy way of saying we're building computers inspired by both the brain and the fundamental laws of quantum physics. How cool is that? So when you boil it all down, the big takeaway here is really a philosophical one. For decades, we've been trying to build complex computers from scratch, piece by painful piece. Reservoir computing just asks a different question. Why build it when we can just find complexity that already exists in nature and harness it?
And that leaves us with one final, pretty provocative thought. If a bucket of water or a bunch of quantum spins can compute, it forces us to ask a much, much bigger question. Are we just scratching the surface here? Could it be that nature itself, the entire universe with all its physical laws, is already the most powerful computer we'll ever know?